Okay, so now we'll start implementing the array unordered list of generic type T. So we'll just create a new class here, array unordered list .java, and then we'll just do class, hit enter. So that's fine, and then we'll just put up generic type T, public class array unordered list of generic type T. Array unordered list, and we'll just say write some doc here. So we'll say array unordered list represents an array implementation of an unordered list. Then under here, actually we already have public class array unordered list, and we'll have to implement. Actually no, we'll have to actually we'll do both. So extends. It extends ArrayList because ArrayList was of abstract class. So now we have all those. So array ordered list is an ArrayList, and it implements unordered list. I just spelled it wrong. Implements unordered list ADT of generic type T. Can't see that because of the recording thing, so that's fine. It's going to say that we haven't implemented all the methods or be declared abstract, so that's fine. And then we'll just write here. So we're going to do the same thing. As the last time. Actually, yeah. So we have our doc. We're going to probably have some more doc here. We're going to put this constructor first, so it's going to be overloaded again. There's going to be two constructors. And we'll say creates an empty list using the specified capacity at param initial capacity, the initial size of the list, then we'll say public array unordered list takes a parameter int initial capacity, so we can enter that as a parameter in the main method later on. We'll use the super keyword to set up the constructor with the parents constructor, or the superclasses constructor. So that's fine. That should be it. Then below we'll overload the constructor with something else. So we'll say creates an empty list using the default capacity. Then we'll just go down here and create another constructor. We'll say public array unordered list, and we'll call the super reference, and it's going to just set up this. It's going to set up this constructor using the supers constructor, and it's going to go to this one, and then it's going to go up here and pass in default capacity into this constructor. A default capacity will become initial capacity. If you're confused with that, just go, we'll we'll probably go through it with a debugger, but you can do that too if you get stuck. Just set some breakpoints. It works in VS Code too. I wouldn't use what's it called? Eclipse, because it's crap. Debugger's crap too. And NetBeans, it's even worse than Eclipse. It's honestly worse than Eclipse. This stuff looks like it's from like 1950. Like it's like really bad. Okay, so the next one we'll do adds the specified element to the front of this list. So this is the add to front method. At param element, the element to be added to the front of the list. Oops. Then we'll say public void add to front t element. So if size, the method we've already created, it's calling from should highlight ArrayList. Yeah, ArrayList of, I don't know if you can see that, but it says ArrayList of generic type T. It's in that class and it's public int size. Give some more information about it. So if size is equal to list.length, so that .length is the array method again. Then we'll call expand capacity. So we'll make the array bigger. Then else we're going to shift the elements up 1. So I'll write a comment. Then we'll do a for loop here. So for int scan points to rear. Scan is greater than 0. Whoops. Scan plus, whoops, scan minus minus. So scan points to rear. So it's kind of going backwards. So it's like it's going backwards. So it's saying scan is equal to rear, which is going to be, so rear is set to 0 initially, I think. See, rear gets set to 0. So if we're adding the first element, we probably wouldn't call this method that we're writing now. We'd probably call it just the add to rear method. Where you can pretend there's an element or two there already. Then we'll say list of scan, array index scan, points to list of scan minus 1. So all that's doing is, so let's just say there's like 5, 6 in the, actually no, let's say there's 6 and 11 in the array list. Whoops. So if we're adding to front, I'll just put that up here. So if we're adding to front, then if the size is equal to the list.length, so our list.length is going to be 5. So that's false. It's going to skip here. It's going to go to here. For scan points to rear, so rear will be like here, I think. Because every time rear at plus plus. So it's going to say list of, for int scan points to rear. So rear is probably 2. So, scan is greater than 0. Greater than, so it's going to only go to this one. It's going to not go to the last one because it's not greater than or equal to. Then scan minus minus list of array index scan, which is at 2, points to list of scan minus 1. So now rear equals 1. list of scan, sorry, no, that's wrong. So list of scan points to list of scan minus 1. So list of scan, which is rear. So scan's here. I can just put like scan. So scan's here. List of array index scan, which is this one, points to list of scan minus 1. So list of scan points to scan minus 1. So it's going to shift the elements up. So you can see list of array index scan, which is 2. So list of array index 2. List of array index 2 points to list of scan, which is 2 minus 1, which is just 1. So list of array index 2 points to list of array index 1. So 11 is going to be copied here. Then it's going to go up to the back to the condition. Then it's going to say for int scan equals, so rear is going to become 1, and so is scan. Actually no, rear is going to stay as rear. Scan's going to become 1 because scan's going to decrement by 1. It's easier in the debugger, that's why sometimes it can be better just doing it in the debugger, but we'll just put scan is here now. List of array index scan. So list of array index 0, 1 points to equals, or points to list of scan minus 1. So scan scan minus 1 is 1 minus 0, because scan is 1 now. So 1 minus 0 is 0. Sorry, no, 1 minus 0 is 1, 0, 1. 1 minus 0 is 1. So it's going to say basically list of scan, list of 1, array index 1. Actually, sorry, list of 1 points to list of 1 minus 1. Scan is 1, 0, 1, 0, 1, 2. Then this one's 1, so list of 1 points to list of 1 minus 1. So list of 1 points to list of 0. So 6 will get moved here. Then it'll go back to the top of the condition for scan is equal to rear, which is 2. Scan is greater than 0, which is this index here. I'll just put 0, 1 and array index 2, which has the value 11. So int scan is points to rear. So scan is equal to rear, scan is equal to 2, scan is greater than 0, not equal to, scan minus minus. So if scan is greater than 0, that means if we decrement scan and it becomes 0, 0 is not greater than 0, so that's false, so it's done. Then it's going to come down here, and then it'll say list of array index 0 points to element. So the element that we're going to add in the parameter, let's just say we're adding, what was it, the numbers? We're going to add 5. So list of 0 points to 5. Rear plus plus, so rear is going to be Right now rear's at 2. We're going to add a 5 here. Whoops, 1, 2. So index 2, index 1, and index 0 right here. Then reroll plus plus, reroll will become 3 because this is index 0, 1, 2. Whoops, we have 2 6s here. Actually, no, I messed that up. This should have been array index 0 was 6. Sorry, array index 0 was 5. 6 got moved up, shifted up by 1. And then rear is not 2 anymore. It becomes 3. That's why we'll just go through in the debugger once again, just to clear up any confusion if I confuse anybody. Then we'll just increment mod count plus plus. So we'll do the next one. That just adds to the front. We were just imagining that we had some elements in there already. After we do this method, it's going to should clear up any confusion. Because this method is the main one when you add. Usually just use this one. So adds the specified element to the rear of this list. So even if there's no elements, it just adds the first one. Add param element, the element to be added to the list. Then we'll say public void add to rear, takes a t element. So we'll say if size is equal to list.length, then expand capacity. Whoops, what happened there? So if size is not equal to list.length, then this will get skipped. We'll come down here, then we'll say list of array index rear points to element. So if rear is 0, according to the object instantiation here, we're going to instantiate our array list of some type, like array unordered list. I'll show you. After we'll instantiate an array list object. Well, we can't instantiate this one, but we'll instantiate an unordered list first. And then it's going to set it up with this constructor, so rear is going to be set to 0. The rear field, or the instance data here. T-array list will become our array list. Mod count is just going to keep track of our iterator. Then when we add the element here, when we add the element, list of array index 0 is going to point to our element. So if we're adding 5, then list of 0 will become 5, list of array index 0. Then here we'll say rear plus plus, so rear will become 1. Then mod count will increment by 1. So this one's pretty easy. Like it should be able to understand this one, because rear was 0, and if we add 5, then list of array index 0, because we're substituting 0 for rear, will point to 5, or will equal 5. Then rear will shift up 1, it'll become 1. So it says, okay, our array list has 1 element in it, size of 1. So our list.length will be 1, and the next element array index it's going to go into the next element. If we add 6, will go into array index 1. So it's like top from the array stack. Should be like top. We're just using it differently. So we just have like one more, and then we'll do the unordered list as well, which just has 1 or 2 methods, I think. Then we'll test the find and that contains 1 method as well. So we'll say adds the specified element after the specified target element. So we'll say throws an element not found exception. I don't think we did that one yet. We'll have to do it probably right after this. So if the target is not found, I think it's asking what it is because we don't have it here. I just have empty. Okay, we can do it. It's just a small class. So we'll just say here element, the element to be added after the target element. And this is the add after method. Then I'll take a param here, target. The target that the element is to be added after. So public void add after. So this can add into the middle of the list, because ArrayList you can add, or linked list you can add to the middle, or the front or the rear. So t target takes a parameter. So if size is equal to list.length, expand capacity. We'll say int scan equal to 0. Here we'll say find the insertion point. We'll use a while loop while scan is less than rear and target does not equal list of scan. List of array index scan. Scan plus plus. Scan, what happened here? Scan plus plus. So that's saying while scan is less than rear and target does not equal list of scan. Scan plus plus. So it's going to see for the target if the target's in the list, and if scan goes through the list and it doesn't find the element, then we'll throw the element not found exception that we haven't created yet. So we'll say if scan equals to rear, which means that it got to the end of the list. So if we have 5, 6, 11, or 5 and 6, at least just 5 and 6. If it went to rear, it goes to rear equals 2. If scan equals to 2, then 11 wasn't found because there was only 0 and 1 index, which had 5 and 6. So we'll do the debugger. We'll do a run through. So throw new element not found exception, and then unordered list. Yeah, I don't think it's probably wondering that we don't have this one. We'll just do it after. So unordered list. Then scan plus plus. Then we'll shift the elements up 1. Actually, I'll put this up here. Shift elements up 1. For int shift points to rear. Shift is greater than scan. Shift minus minus. List of array index shift points to list of shift minus 1. So again, we'll just go through this through the debugger because it's gonna take longer to think of it. So don't worry, we'll do it in a sec. Then we'll say insert element. So list of scan points to element rear plus plus and mod count plus plus. We can just have a look here. So for int shift equals to rear shift is greater than scan shift minus minus. So it's doing the same thing we just did somewhere here. It's doing the exact same thing, so nothing complicated. It just changed the name to shift instead of scan, because we already use scan here. You can use I and J. I prefer to use I and J. It actually seems a lot easier and less confusing. But I'm just doing this way to practice, just in case you have to read someone else's code or like a textbook example or a test, then you'll have to know, you have to practice with the other names other than I and J. But it seems like it's harder. It's just the same thing. So it should be fine. Then now we'll just do the how many more? We just have one more. The array unordered list, or just ordered list. Oh yeah, array unordered list. So we have to create this one too. So we'll just create the unordered list first, or just the ordered list. So we'll say array ordered list .gava. We'll do generic type T here, and extends ArrayList again, because array ordered list extends ArrayList, and it implements array ordered list ADT of generic type T. So we'll say array ordered list represents an array implementation of an ordered list. Then we'll have the constructors here again, same thing. Exact same way we did the other one for unordered list. So we'll have some doc here that says creates an empty list using the specified capacity. Initial capacity, so add param, the parameter will be initial capacity, the initial size of the list, public array ordered list. So that's just a constructor, and then int initial capacity. Then we'll call the super reference. We'll pass in initial capacity. And then under here we'll have the overloaded constructor again with no parameters. So we'll say creates an empty list using the default capacity. And we'll say public array ordered list We'll just call the super reference here, and that's it. It'll set everything up. So just one more method. Actually, we have to do that exception class, but just one more method. So this one, it's a little bit extra stuff. There's going to be some extra stuff in here because it needs a comparable element. So we'll say adds the specified comparable element to this list, keeping the elements in sorted order. Whoops. At param element, the element to be added to the list. So public void add t element takes a object of type t. You can call it obj if you want, or whatever. Then we'll say if not element. So if element is not an instance of, that's lowercase, I thought it was uppercase. Okay, so comparable. If element is not an instance of comparable, so if element is not an object of, you can just think of instance as object, so if element is not an object of the comparable class, then throw a new non-comparable element exception. We may have to do 2 exception classes. Then we'll pass an ordered list. Yeah, we're going to have to do 2 exception classes. Then we'll say comparable of generic type t, comparable element is points to casted comparable of generic type t to element. That's going to tell me it's unchecked. So you can do suppress warnings if you want. It should work though. So if size equals to list.length, expand capacity. I'll just write it. Expand capacity. So it checks if the list is full. If not, if it is, then it's going to expand the capacity. If not, it'll skip down here. We'll set scan to 0 again. We'll do the same thing. We'll find the insertion location. Find the insertion location. So while scan is less than rear, and comparable element dot compare to. So it's not exactly the same. List of index scan is greater than 0. While scan is less than rear, and comparable element dot compare to list dot compare to list of array index scan is greater than 0. Scan plus plus. So while scan is less than rear and comparable element dot compare to list of scan is greater than 0, so so the compare to method, this should be a built-in one, I think. It's in maybe the integer class. It's been overridden somewhere, but there's a compare to method. There should be a built-in one. I believe somewhere it's going to return -1, 0, or 1. You can also override it to compare whatever you want. We did a video on this, I think. So basically it compares this object with the specified object for order, returns a negative integer, usually -1, 0, or a positive integer, usually +1, if the integer is less than, equal to, or greater than. So if the first element is less than the second one, it should return -1. So we'll test that. And then we'll just shift elements up 1. We'll shift existing elements up 1. We'll say for int shift points to rear. Whoops, not and, sorry. Int shift points to rear, and shift is greater than scan. Shift minus minus. List of array index shift points to list of shift -1. Yeah, I don't think we're going to be able to debug everything in this session. We'll have to compile the videos. But this is going to be a long video, maybe like 3 hours. So insert element. List of scan points to element. Actually, maybe not. This is just the hardest method here. Not hard, it's just long. So we'll say list of scan points to element, rear ++, and then mod count ++. So we've seen this, it's going from the end of the list back to 0, so it's going backwards again. We don't use this too often, so it can be a little slow if you don't practice with it often. Going backwards. Should be everything. We probably have some mistakes somewhere. And we need the element not found exception and something else. So we'll create a class here. Whoops. We'll create a class element not found exception. And then we're going to need, I think it's a no such element exception. No such non-comparable element exception. Damn, do we need more than one? Sorry, do we need 3 of them? Ordered list. Or is this built in? Yeah, I think we need 3 classes. So let me see. I'm just checking my notes to see which one we need. This is chapter 15. Okay, so non-comparable. I think we still need a no such element exception, but we'll do this one. Element not found exception. So we'll just say, where is it? Element not found exception here, public class element not found exception. We'll have to extends runtime exception. So it is a runtime exception. Then here we'll just do a note here. Element not found exception represents the situation in which a target element is not present in a collection. So public class element not found exception. Public class element not, whoops, we need the F to be capital, I think, yeah. Element not found exception takes a parameter string collection. Whoops, no class. Public element not found exception string collection. We'll pass in super. We'll put a message, the target element is not in this. We'll concatenate with collection. And then we'll put another doc here. We'll say sets up this exception with a message. We need 2 more, I think, so we'll do 1 more. I have some viewers asking for more videos, but I have no idea when I'm gonna upload these because I still have to make so many at the same time, so I'll try to upload one. I'll try to upload a few a week. But it's gonna take a long time to upload these because I have to compile it, maybe edit some little bit, some parts of it. So here we'll say, we'll create another class, non-comparable element exception. I will have to probably edit some parts of these videos just to compile it, so it can take a while. I'm not a pro YouTuber or anything. I don't really make videos. I don't know how to make them. I just do the coding and some trading stuff, so it takes a long time. So public class non-comparable element exception extends runtime exception. Extends runtime exception, needs an E here. So public class non-comparable element exception extends runtime exception. We'll just do another doc here, non-comparable element exception represents the situation in which an attempt is made to add an element that is not supported. Oops. Is made to add an element that is not comparable to an ordered collection. Then we'll do the doc for the constructor. We'll say sets up this exception with an appropriate message. At param collection, the exception message to deliver. Then public non-comparable element exception takes a parameter string collection. Call the super reference, and we'll say the concatenation again, plus collection plus requires comparable elements. Done. Save it. We still need a no such element exception, I believe, but I can't find it anywhere. Because if we run this, actually we don't have anything, so we'll have to say, we'll do the unordered list first. So unordered list, whoops no, array unordered list of type integer list. Well, actually we'll call unordered list because we have two, points to new array unordered list of type integer. Does it take parameter again? Does it take a parameter? Okay, so we can set it up to take a parameter, so we'll just set it up to take 5 for initial capacity, and we'll say unordered list dot add to rear. We'll add 5, save it and run. I think we still need some exception class. And we probably have a mistake somewhere too. Okay, no we don't. I thought we did have a couple errors. Okay, that's fine. But that's... should we print it? So system.out.print. We do a toString, I think we did, so print array. And we'll print unordered list just to see if it works. It does work, but I thought we were getting, before we were having an error for a no such element exception. No such element exception, element not found, we finished it. I don't think I was dreaming. I did see it somewhere. No such element not found. This needs a capital. Should be a no such element somewhere. I thought I did see one. Concurrent modification, unsupported operation, exception. No, I thought I swear to God I saw one somewhere here. No, it was recently, so it was here. No such element, nothing. Okay, so I guess I was dreaming then. So if it works, then we'll just add 5. We'll add 6. So let's just see what's happening. Let's set a breakpoint. We'll debug this. So if we're finished, then we'll just debug it. I don't think we'll get through everything right now. Might have to take a break. Because how many methods do we have to do? So let's just see how many we have to do. We have to do constructors easy. That's easy. So remove last, 1, 2, 3 we'll remove. First, last we'll skip. Contains we'll have to do, so that's pretty much 1, 2, that's 4. Oh, we will skip iterators. Right now we'll use it later. So save this class. yeah, this will take at least another hour to debug. So we'll just do some now. For you it'll be one video, but for me I'll take a break. I'll probably do it tomorrow, but we'll just so we started debugging here. So we can see we have our command line here, args. We'll step into this line because we're in this one, the blue line. Step in. So we passed in 5 for initial capacity. So now we're going to call the super reference and pass in initial capacity. So it's going to go to the super classes constructor. So we'll step in. So it's going to go to ArrayList. So ArrayList, it's going to carry initial capacity to here. It's going to pass initial capacity in. Initial capacity. Initial capacity. Super reference. So go to the super classes constructor, pass in initial capacity. The one that takes one parameter. Pass in initial capacity. Then rear points to 0. Excuse me. So rear points to 0. And list points to T, so casted T array to new object of array index initial capacity. So remember, you can't instantiate an array of generic type T. You can't instantiate anything of generic type T. Generic type T can't instantiate objects. So we have to cast it to the object class. So our object reference here, ArrayList. Then we set list point to casted T array to new object array of initial capacity. So it's just going to instantiate our array here. So list of 5 elements, index 0 to 4, and it's an object array. Then we'll set mod count to 0. That's done. That's done. So we have everything. Our object was instantiated, our unordered list. Then we'll go unordered list. We'll go to the method add to rear. So we'll pass in 5 as the element. If size points to list.length. So if size, which should be 0 right now, step in. Size just returns rear. So rear is basically count, or it's like top. So right now it's 0. So if 0 is equal to list.length, which is 5, list.length here, our array has 5 indexes in it. Then expand capacity, but that'll be skipped because this is false. So list of array index 0 points to the element 5. Here we have our list. So array index 0 is holding an integer object at memory location 957. Rear will increment by 1, plus 1. Rear is now 1, mod count will increment by 1. Done. Skip, actually we'll stop.